Welding steel. Nailing wood. Techniques for joining commonplace materials are also pretty commonplace. Then along came plastics, and more plastics. In fact, 20 different families of plastic materials. These versatile new engineering plastics required newer, faster, more efficient joining techniques. At the same time, many of these plastics inherently possess the properties needed for efficient joining. The purpose of this film is to examine in some detail the various methods of joining plastic parts. Plastics generally, and more particularly the DuPont engineering plastics, offer the advantage of a wide variety of joining techniques. In some applications, the shape and function of the part dictate the joining method. On the other hand, this versatility of fastening permits designing around a specific assembly method for faster production and lower part costs. As a service to its customers, continuing research and development by DuPont's plastics department have contributed substantially to the various methods of joining plastic parts. Whether the part determines the joining technique or vice versa is based on such considerations as design requirements, end-use properties, production methods, and the economics involved. Each of these applications of DuPont plastics is joined by a different technique. Spin welding, heading, self-tapping screws, snap fits, press fits, hot plate welding, molded-in threads, and ultrasonic welding. Since some of these techniques are relatively new, let's take a closer look at each joining method to see if it might provide you with some new profit opportunities. Spin welding is ideal for joining circular parts, such as this water filter of DuPont Delrin acetal resin. In spin welding, two surfaces rotate against each other at high speed, creating a small area of melt at the interface. This technique can be done on readily available high-speed production equipment. This close-up view shows the strong, neat, leak-proof joint that was made in a fraction of a second. The top part of the filter is held in this cone-shaped jig and is spun against the bottom part. After melting occurs, rotation is instantaneously stopped and pressure is maintained for a moment until solidification takes place. Actual rotation is less than a second. Thus, production rates of 600 to 1,000 parts per hour are common in spin welding. The spin welding technique is used to insert watertight, pressure-tight plugs in this water softener valve, which is molded of Delrin acetal resin. Self-tapping screws are widely accepted as a rapid and inexpensive means of joining plastics. For example, self-tapping screws are used to join solenoids to a valve body of Zytel nylon resin in this clothes washer water valve. Pneumatically operated torque drivers working to a predetermined torque make quick work of assembling these valves on the production line. The finished water valve uses 15 self-tapping screws. Tough, resilient nylon holds these screws tightly despite vibration and fluctuation of temperature. Heading is similar to riveting in that the end of a cylindrical pin is compressed to form a head. This Delrin part with a molded-in pin is being permanently joined to a sheet of lucite acrylic resin. When the design conditions permit, cold heading is usually suitable for most applications. You can see the mushroom effect as the pin is deformed in this cold heading operation. Components of this pump and pillar, molded of Delrin, are being hot-headed to provide a tighter joint with less pressure on the parts to be joined. Hot heading is easily accomplished by heating the heading tool. The two parts of the impeller are compressed before heading to ensure a tight fit. In this assembly operation, 10 separate molded-in pins are being headed at one time. Any flash that is formed can be easily removed. Dissimilar materials can also be joined by heading. Here is a metal washer. It's permanently attached to the extended shaft of a Delrin gear. This component is used in a new battery-operated clothes brush. This close-up view shows how quickly and easily these parts can be joined. The washer is positioned, the heading tool is applied, and presto, the parts are tightly, lastingly joined. Some plastics, like DuPont Lucite acrylic resins, can be joined effectively with adhesives. The use of adhesives is common in custom work. A good example is the sign industry, where fast, tight bonds are required. These clear sheets of lucite are being joined, literally welded, by applying a solvent cement. See how the capillary effect distributes the solvent evenly along the surfaces to be joined. This saves a lot of valuable time on the production line. Here is a sign in the making. Letters molded of lucite are placed in the sign background with proper spacing and alignment. And a solvent cement is brushed on, and a neat, tight, permanent joint results, suitable for both interior and exterior use. The solvent cement is being used to join this spacer to a signboard letter molded of lucite. The spacer adds a three-dimensional effect to the sign, makes possible a tight bond on a patterned surface, like these red and white plaques, also molded of lucite. Ultrasonic welding is a relatively new technique for joining plastic parts and requires the basic equipment you see here: a power source, controls, and a metal horn that fits the configuration of the parts to be fastened. The component parts of this small box molded of Delrin are being joined by ultrasonic welding. The horn transmits mechanical vibrations of 20,000 cycles per second to the white cover. The resulting impact of the cover against the body of the box generates enough heat to cause a melting at the joint interface. A short hold cycle while maintaining pressure on the parts, and you have a strong, leak-proof joint in a matter of seconds. See how quickly a clear reflector element molded of lucite is joined to a lucite taillight lens by ultrasonic welding. Parts in place, horn is positioned, and you can actually see the melting taking place. The finished lens is now ready for the assembly line. Behind the grill in this battery-operated clothes brush is a lint screen of woven nylon filament, permanently attached to the Delrin housing by ultrasonic welding. Here's how it works. When welding dissimilar materials by ultrasonics, Delrin and nylon in this case, a mechanical bond is required. In this production operation, the horn causes the nylon mesh to vibrate against the Delrin housing. With its lower melting point, Delrin flows around and through the mesh, creating a secure mechanical bond when it cools. The entire joining operation only requires about 6 seconds. The natural resilience of many plastics makes possible the snap fit, a simple and inexpensive technique for making strong mechanical joints. A good example is this detergent package. The push-pull closure of Alathon polyethylene is snap-fitted into a screw-on cap, also molded of Alathon. In this close-up view, you can see the ring on the closure that snaps into a retainer molded into the cap. The simplicity of the snap-fit technique makes for high-speed production. These closures are being snapped into place on this machine at the rate of 180 per minute. The resilience of Alathon makes the snap-fit possible, and its recovery and toughness keep the closure in place for keeps. Hot plate welding is a frequently used method of fastening similar plastics with a strong, permanent, leak-proof joint. This joining technique is easily performed in the field as well as in the plant. Mile after mile of this L to A pipe has been joined by heat fusion. Hot plate welding equipment is relatively simple. A heating tool is required, which usually has a variable temperature control. A thin layer of Teflon helps to keep the molten plastic from sticking to the primary heating surfaces. The heating tool creates a thin band of molten plastic inside the pipe coupling. The other face of the heating tool makes a similar melt on the chamfered end of the pipe to be joined, which you can see here. Then the two sections are pressed together. And here's the result, a neat, leak-proof joint made by heat fusion in less than 60 seconds. Components of this automatic window control, molded of Delrin, are joined by hot plate welding. The two surfaces to be joined are heated on the metal plate until they melt. Then the parts are simply pressed together for an instant until solidification occurs. The resulting joint is virtually as strong as the material itself. In hot plate welding, some trimming of the melt bead is often necessary. Here's the finished part after trimming. This motor connector of Zytel nylon utilizes another widely used technique for joining plastic parts, molded in threads. The economies of this joining technique are realized by including the threads in the original design. Thus, costly machining operations are unnecessary. Not only is Zytel an electrical insulator, but the threads of this tough, resilient plastic will not freeze, as metal-to-metal threads sometimes do. The molded-in threads are more than strong enough to withstand repeated joining and disassembly. Notice how smoothly the male and female parts of the motor connector are joined when the thread sleeve ring is tightened. The end caps are also attached by means of molded-in threads. This is the bare chassis of an oscilloscope. Over 50 separate parts molded of 4 different DuPont plastics are fastened to this chassis by means of press fits, another effective joining technique. Press fits rely solely on the interference between two parts. The producer of the oscilloscope enlarged somewhat on the press fit technique. By applying some sound engineering principles, this firm developed several unique tools for installing the various plastic parts that resulted in faster assembly and more positive alignment. Better alignment, in turn, helped reduce breakage of delicate electronic components. Here is one of these special tools in action. Here's a press-fit sandwich with a chassis in the middle. Sockets like these are press-fitted into the chassis. Other press-fitted plastic parts include fasteners, clamps, grommets, and bushings. Press fits are quickly and easily done. Notice the flange on this condenser socket of DuPont Allothon polyethylene. This part is snap-fitted into the chassis for greater retention. And here's the oscilloscope chassis with more than 50 plastic parts, quickly and securely press-fitted into place. This film has presented a brief review of a wide variety of cost-saving techniques for joining plastic parts: spin welding, self-tapping screws, cold and hot heading, cementing, ultrasonic welding, hot plate welding, molded in threads, press fits, and snap fits.